So playing with right angle trigonometry, section 5.5, question number 2. So we're given some information about a triangle. Note, this triangle may not be drawn to scale. Okay, that's a good thing to know. They give me this angle A, which is 35 degrees, and then they want me to figure out some stuff. Now math, remember, is case sensitive. So little b is different than big B. Little b is a length, big B is an angle. I'm gonna redraw that triangle. And let's see, I have a 35-degree angle, which is supposed to be A. So I'm gonna try and, that doesn't look like 35 to me. That looks more like 60 or maybe 55, I don't know. But it's not 35, that's for sure. So I'm gonna start off with a line there for the base. Let's make it right there. And then I wanna make a 35-degree angle. So right, that would be 90, 45 somewhere over here. I think 35 would be around there-ish. And there-ish. So I think that is more what this triangle is going to look like. And then let's label some stuff. So here's my right angle. This down here is my 35 degrees. And remember, this angle up here has to be complementary to it. Complementary means it adds up to pi over 2 or 90. So angle B up there, that's what they were calling B, in degrees would have to be 90 minus 35. Let's see, 90 minus 30 is 60. Take away another 5, it ought to be 55 degrees. Okay, and they have the degree the degree word out there, so I would just put in 55 here. All right, so I've got that. They tell me length A is 7. And they want me to then figure out what length B here is, and length C is right there. All right, so let's see, what can we do to figure that out? We know Pythagorean theorem that B squared or A squared, 7 squared plus B squared has to equal C squared. So that gives me 2 unknowns, so that doesn't quite help yet. What else do I know? Well, I know that the, say, sine of 35 degrees would be 7 over C. So then I could solve this for C. That should work, right? So if I solve for C, I would multiply the C to the other side. So C times the sine, 35 degrees, has to equal 7. Divide the sine over, so C would have to be 7 over the sine of 35 degrees. So now I know what C is. Now 35 degrees is not a special angle. So this is going to be kind of a messy number on the calculator. And the question is, oh, it says to round to 1 decimal place. Now this would be a mistake to calculate that number, round it, and then plug it into the equation above. All right, what do I mean by that? If I plug this into a calculator to find C, and I round it to 1 decimal place and then plug it in here, I'm then compounding my rounding error. So I want to avoid that if possible. So here's the way I will go about it. I will get that on the calculator, but I'm going to hold on to its value. So let's try, let's use Desmos this time. Let's see, Zoom, you're in my way. Let's move you down there maybe. Okay, and let's just clear some stuff from before. Okay, so I'm just gonna write C equals, you can do that on Desmos, and then 7 divided by the sine, and then I'm gonna have to make sure I'm in the right mode. So let's see, where does this calculator let me pick degrees? I think it's the monkey wrench up here. Degrees, all right, so it's set to radians, I'm gonna set it to degrees. Again, always make sure your calculator's in the right mode. And so then I can go here and put in my 35. And I get C should be 12. Now remember, I tried to redraw my picture to be more accurate. So let's see, what did it say, 12.2-ish? Yeah. So in my picture, and again, so I did my best estimate of 35 degrees. That doesn't look too bad. 7, C has got to be quite a bit longer than 7. So yeah, 12.2 seems reasonable. So this right here, my C is approximately 12.2, whatever units I'm working with. Now that I know C, I can easily find B based on that up there. So let's bring that down to play with. So we have 7 squared is 49 is equal to, no, plus B squared, sorry, I lied. Plus B squared. And I'm just going to leave it as C squared for the moment, and then I'll plug in this number after. I want to solve here for B this time. That's what I don't know yet. So I'm going to subtract the 49 over. So C squared minus 49, and then I would have to take the square root. So B would be equal to plus or minus the square root of C squared minus 49. Now, some of you might be tempted to take the square root of 49, but the order of operations here says you have to square C, then subtract, then take the square root. So that would be an illegal mover to try and to take a square root ahead of time. Here I'm looking at lengths, so I really don't care about the minus part, so I'm just going to get the square root. So now I just need to take whatever number I had for C, plug it in here, square it, subtract 49, take the square root, and Desmos is ready to do that. So I don't even have to deal with any rounding error because I said, hey, C equals. So I want the square root, come on, square root of 49. I don't know, I want the C first, right? So I want C squared and then minus 49. Did I type that right? Let's look back at my notes. C squared minus 49, and then take the square root. Yep, that looks good. So I'm getting about 9.997 to 1 decimal place. That would be 10.0. So B is approximately to 1 decimal place. And again, avoid rounding intermediately, which I let the computer do for me, is about 10. So B is about 10 and C is about 12.2. Does that seem reasonable on my picture? If that's 7, I think this is about 12-ish, approximately 12. That was a little messy. Approximately 12, about 12. And this one right here, I think is about 10. Yeah, 12. The hypotenuse has to be the biggest side. And it's just a little bit bigger than B down here. And both of them are quite a bit bigger than 7. Okay, so it helps to try and draw your picture to scale to the best of your ability. There are programs you can actually tell it to draw a 35-degree angle, which I'll show some other time. All right, cool. So how did I check this? I check this by looking at my picture. So draw a picture, draw a picture, draw a picture. If you forget, draw another picture.